From motors to battery packs, we will break down the technology driving to the shift to a cleaner, more efficient future of transportation. Me, Zaid Momini, and my teammates Malik Bani Milham, Usama Momini, and Hamdan Jadallah are going to take you to a small trip to an EV powertrained world. The automotive industry has become one of the most important worldwide industries. There are more technological elements that are being introduced on the vehicles towards the improvement of both passengers and pedestrians' safety. In addition, there is a greater number of vehicles on the roads, which allows for us to move quickly and comfortably. However, this had led to a dramatic increase in air pollution levels in urban environments. Therefore, the authorities of most developed countries are encouraging the use of electric vehicles to avoid the concentration of air pollutants, CO2, as well as other greenhouse gases. An EV powertrain refers to the system in an electric vehicle that converts electrical energy into mechanical motion. A powertrain is a set of components inside a vehicle that generates and control power to thrust the vehicle into motion. Electric vehicle powertrains have many components, such as battery pack. The battery pack is made up of multiple lithium ion cells and stores the energy needed to run the vehicle. Battery packs provide direct current output. DC to AC converter. The DC supplied by battery pack is converted to AC and supplied to the electric motor. Electric motor. It converts electrical energy to mechanical energy that is delivered to the wheels via signal ratio transmission. Onboard charger. It converts AC received through charge port to DC and controls the amount of current flowing into the battery pack. Battery management system. A BMS continuously monitors the state of the battery. DC to DC converter. The battery delivers a fixed voltage, but the requirements of different accessory systems in the EV would vary. Thermal management system. It is responsible for maintaining optimum operation temperature range for powertrain components. Body control module. The BCM is responsible for supervising and controlling the functions of electronic accessories. In a motor, torque speed profile is critical. It defines the heart of its performance. Here are two samples of torque speed profile of permanent magnet synchronous motor and switched reluctance motor, and it is clear that the PMSM gives high reluctance torque. However, one of its major shortcomings that they have low constant power region as shown.
Battery technology, the driving force. The foundation of any electric vehicle powertrain is the battery. Improvement in battery chemistry, like the development of lithium-ion batteries, have transformed electric vehicle. These batteries offer more energy, charge faster, and last longer, allowing electric vehicles to travel further on single charge. Motor efficiency, unlocking performance potential. Efficient motors are essential for getting the best performance from electric vehicles. Permanent magnetic synchronous motors are popular because they are small, highly efficient, and produce strong torque. Recent improvement in motor design, like using better material and optimizing the arrangement of magnetic have boosted their power and overall efficiency. Power electronic enabling seamless energy flow. Power electronics are a key link between the battery, motor, and the other parts of an electric vehicle's powertrain. They include devices like inverters, converters, and motor controllers that control the flow of electrical energy to improve efficiency and performance. Advances in power electronics have cut energy losses, improved cooling, and made powertrains more powerful and compact. Now, materials like silicon carbide and gallium nitride are set to make this system even better, allowing for faster switching speeds and lower energy losses. Intelligent software empowering powertrain optimization. Intelligent software is playing a crucial role in modern powertrain. Advanced algorithm and machine learning can improve efficiency, adjust to different driving conditions, and boost overall performance. By using real-time data and analyzing driver behavior, this system can optimize energy use, predict maintenance needs, and provide personalized driving experience. As vehicles become more connected and integrated with the power grid, this software solution will be even more important for efficient energy management. Electrification beyond passenger cars. Evolution of powertrain technology is propelling the electric vehicles revolution forward. From advancement in battery technology to optimizing motor power electronics and intelligent software, every aspect of the powertrains is undergoing rapid transformation.
In general, EVs have many advantages like zero emissions, simplicity, reliability, cost, comfort, driving range. And here is a comparison of savings in cost per kilometer offered by vehicles powered by fuels.
Motor efficiency and power use. Electric motors are very good at using electricity. Most of the battery's power is used to move the car, and only a little bit is lost. This helps the car go farther with one charge. Example for motor controller, we talk about this in class. Armature voltage control in rotate. How does it improve performance and efficiency when using armature voltage control? At low voltage, the motor rotates slowly and energy consumption is low, suitable for slow driving or city traffic. At higher voltage, the motor spins faster and produces more torque, which is useful for acceleration or climbing hills. Field controls. It is a method to control magnetic flux in stator. When the magnetic field is weak, the motor spins faster. When the magnetic field is strong, the motor spins slow. How does it improve performance and efficiency? At high speed, the magnetic field is weakened, allowing the motor to spin faster without using extra energy. At low speed, the magnetic field is increased, giving the motor more torque for starting. Performance improvements. We can improve the performance and increase the efficiency of an electric car by motor controller. An electronic control unit is used to manage the amount of electricity sent to the motor. This unit can accurately control speed and torque, reduce electricity consumption.
So now let's talk about the challenges that Tesla is facing in the year 2025. As many of you know, Tesla has been one of the most important and influential companies in the electric vehicle industry. They have changed the way people think about electric cars. But now, things are getting harder. and the company is dealing with several big challenges that could impact its future success. First of all, let's talk about the government regulations and legal issues. One of the biggest challenges Tesla is facing right now is pressure from governments and regulatory agencies. Tesla's full self-driving system, which is also known as FSD, is being looked at very closely. There are new laws and safety standards the company must follow, especially when it comes to autonomous driving. That means Tesla has to make changes to its software to meet those standards, and that can be expensive and time consuming. Also, Tesla has been involved in lawsuits where people claim the company gave the wrong impression about how advanced its self-driving system really is. In California, for example, the Department of Motor Vehicles has investigated Tesla for possibly misleading marketing. All of this legal pressure is forcing the company to be more careful with how it promotes its technology. Secondly, let's talk about the intense competition from other car makers. Another big challenge is the amount of competition Tesla is facing right now. A few years ago, Tesla was almost the only name in the electric vehicle world. But today, big traditional car companies like Ford, General Motors, and Volkswagen, they have entered the market in a big way. They have launched electric models that compete directly with Tesla's cars and sometimes at lower prices. There is also huge growth coming from Chinese companies like BYD, NIO, and many other companies. These companies, they are not only getting support from their government, but they also become really good at making affordable, high quality EVs. In fact, BYD has already passed Tesla in total global EV sales, which shows just how serious the competition has become. Third, let's talk about the supply chain and production delays. Tesla is also struggling with supply chain problems. Like many other tech and car companies, for example, there is still a global shortage of semiconductors, those tiny chips that power things like self-driving system, the screen, and other features in the car. Without enough chips, Tesla can't produce as much vehicles as it wants. On top of that, there is high demand for materials like lithium, which is crucial for making electric car batteries. Tesla is trying to fix this by partnering with mining companies to secure its own supply, but that takes time. Tesla is also trying to grow by building more gigafactories. They are planning one in Mexico and expanding that one in Germany. But both projects they have run into delays, mostly because of regulations and construction issues. So even though they want to grow fast, these problems are slowing them down. So to sum it all up, Tesla is still a strong and innovative company. But 2025 is definitely a challenging year. They have to deal with stricter government rules, legal pressure, strong competition from other car makers, and production delays caused by supply chain problems. So if Tesla can find a smart way to adapt, improve their technology, and keep up with the global demand, I think they will continue to be a major player in the EV world. But if they don't act fast, other companies might catch up or even pass them.
Finally, electric vehicles hold great promise to replace internal combustion engine vehicles. Many studies predict that electric vehicles will play a big role in the future. This is clear from the large investments being made in developing EVs, building charging stations, and improving battery technology and supply chains. As more people start using EVs and the technology gets better, this creates a positive cycle where better, cheaper technology encourages even more people to switch to EVs.